They're called conic sections. And this is kind of one of those standalone type units that, for the most part, we used to save this one for the end of the school year. And it was normally just taught in, Algebra 2, but it's just at the very end. When the honors program came around, I decided that it was a perfect spot to talk about conic sections right after we got done with quadratics. Why? Because a parabola is a conic section. So parabolas are conic sections, and I kind of alluded throughout the course of completing the square and all that kind of fun stuff, is that it's one of those skills that is very, very easy to use in this unit. Also, full disclosure, being the math team coach, this is a test of the math on the math team. So it's usually never taught. It's a senior level test, but this section is still taught in pre-calc, but at the very end of the year. So I thought, hey, what a great idea. I could have like a self-fulfilling prophecy here by helping students that are probably on the math team in an honors algebra 2 class. Devin. And joking. Hey, I'm not going to be able to make it for your spelling bee thing. Good luck tonight. I can spell bees. Oh, darn it! Anyway, so conic sections is one of those standalone things. It usually takes about 2 weeks to get through. It's not a very long section, about 5 sections or so to go through. We're going to look at parabolas, circles, ellipses, and hyperbolas. Within all of those, there are specific equations, specific formulas, and how things work. I will not make you memorize formulas in this unit, but you will still have to know how to use parts. Okay? It's a pretty straightforward thing. So actually, the 2. What time is it? 18. All right, you'll think it's close to that. So parabolas. As of right now, you guys know this. We're actually going to get the A out here. Y equals x squared. We okay with that? If it's y equals x squared, can I also write it as x squared equals y? Is that okay with you for right now? It is. Now, the reason why I'm doing that is because when we get into the conic section, we tend to write the equations of these things out just ever so slightly different. And if I'm looking at this, I'm hoping that by now, you guys can tell me what direction is that moving? Up. Why? Because the A value in this case is 1, so this one is your standard old boring up like a cup. Where is the vertex located here? 0. Okay. Now, what happens here with conic stuff that we start to piecemeal together with what you've learned in quadratics with parabolas is that today, especially for these first 4 days or so, every single vertex that we talk about will be centered at the origin. All of them. All of our parabolas will be, circles tomorrow. The reason I'm doing circles tomorrow is because it's really easy and it's a Friday, so there's that. And then we have ellipses next Monday, hyperbolas on Tuesday. The rest of next week, we're going to spend time on shifting them, moving them around in space. H and K. Okay. Now, every single parabola has a vertex. And every single vertex is always looking at something. It's always looking at what's called its focus. Okay. Now this starts to get, are any of you guys in physics? Okay. Have any of you guys ever looked at what an eyeball, well not actually literally looked at an eyeball, but you know what the insides of the eye is, like corneas, retinas, all that kind of stuff? Okay. Anyway, what happens here is that if you start thinking about the way that conics are used in real life, they're actually mapped off of like what your eye does. Wearing glasses, Your glasses all have a curve to them, don't they? Think about what that's doing. Your glasses are curved at such a rate so that you can focus at something. Okay? Contact lenses. Contact lenses also have that curvature to them specifically. That was awesome. He just sits there and goes. So, sorry, Devin. She just did this. It doesn't work. That's the whole point. Now, what happens here, think about the analogy of glasses. Your glasses, when your eyes are looking at it, in the back of your eyeball, there's something that's bouncing off the image. Is that the retina all the way in the back, or is it the cornea? It's something. Anyway, what happens here is that within every parabola, there's going to be something, or there's going to be what's called a focus, what the vertex opens towards. Also, something behind it called a directrix. A directrix is a line that balances out a parabola. Okay? So the directrix will always be behind the vertex. Because the vertex will always, always, always open towards the focus. So if it's opening downward, the directrix is then above it. It's still behind where the vertex is. Okay? That's what that looks like. Now, here's the thing. In order for these things to stay balanced, this distance from here to here and from here to here will always be the same. The distance from a vertex to a focus will be the exact same thing as the distance from the vertex to the directrix. The only thing that's different is going in a different direction. But remember, will distance ever be negative? No, you're going in a different direction. So what we're looking at here today, guys, is that we're going to talk about parabolas in the sense of a conic section. It's a little bit different than what we've done. There's no factoring involved in any of these because all of our zeros will be located at the origin. I'm going to touch it at 1. All of our discriminants are going to be 0 because we'll have one real solution. Okay? Just a matter of which way they're going. Speaking of, that means that instead of just opening up or down, like this, that just means my A value is negative, the directrix is above it. You can go side to side. Now, what happens here instead of going side to side, it's no longer an x squared parabola, it becomes a y squared parabola. Okay? So let me write out a few terms here. We have x squared. We're going to get these generic equations. We're going to have one that's x squared equals 4py. And we're going to have what's called y squared equals 4px. Okay? Now, these two values, what we do here is, if it's an x squared parabola, it's either going to be up, bless you, or down. And it's really easy to tell which way is which. When it's up, that means it's going to be positive. And the other one is if it's negative. Now think about your number line. If it's negative, it's going to go left. If it's positive, it's going to go right. That's how that works. Hold on 1 second. Hey, Maya, you only got 10 minutes, okay? Because you only had 20 from left over from yesterday. All right? Excuse me. So you go through from that. Now, what happens then, for today, all of our vertices are going to be located at the origin. This distance from the origin to a focus is your value of p. Okay? So the distance from the vertex to the focus is going to be this value of p. P will then tell you if it's positive, it means it's going up. If it's negative, it's moving down. If it's an x squared. P is negative if it's a y squared, it means it's moving left or it's moving right. That's where it's dependent upon. Remember, the math that we're going to do today isn't difficult, but what it is that we have to make sure we keep all of our values straight. Because as soon as we start figuring out what everything means within a conic, it all replicates. Yes, sir?
Can you find that focus?
Yes, sir. You have to be able to set it up in a certain format. You have to do some completing the square and doing a bunch of stuff like that, but it is possible. All right. It's not something we normally do with. We have to be able to do the H and K thing, and it's about putting it back from standard form to vertex form. Because vertex form is a shifted conic section forever. Super easy to see once we get there. Okay. Now the other thing is when we're talking about this directrix. If P is positive, then the distance to the directrix would be negative. And these lines, if you have an x squared parabola, it means it's moving up or down. That means your directrix is always going to be y equals some number. Yes, sir? Different direction. So if P is 2, it means it went up 2. Then the counterbalance, you have to go down 2. This that distance between those two is always going to be the same. Okay, from vertex to focus is going to be the same as vertex to directrix. So that vertex is at the midpoint. It always works. Whereas if I go the other one, if I have a y squared parabola, I still have what changes is that p-value still tells you what direction you're going, whether you're moving right or left, and p is positive, think about the number line. Going to the right is positive, going to the left is negative. And it's going to be super easy to see as soon as I throw an example. But I just want to get down on paper what things look like, especially here, what's the equation of your directrix going to be if you have a y squared? Exactly, it's x equals number. You know what really easy to remember? In an x squared parabola, you have a singular y. In a y squared parabola, you have a singular x. That's a really easy way to remember that. It's a really, really easy way to remember that. And plus, remember, think of it this way. The directrix, you want to think of the directrix as an arrow. The arrow wants to go through the parabola. It wants to touch it twice. Okay? The arrow wants to touch it. That's all put together. But anyway, okay? Let me show you an example of what this looks like written out in terms of conic sections. Okay? I'm going to rough sketch this and identify my vertex, focus, and directrix. I know everything's located at the center right now, so your vertex can be really easy for everything for the next few days. But eventually, we're going to have to find out where things have moved. So it's just kind of, you'll just get in the customary to me saying, hey, what's your center? Where's your center? Well, here it's at 0, 0. Good. Answer. Is this an x squared or a y squared parabola? Y squared. So I know it's going to move left or right. What direction is this going to move? Y. Negative. I know it's going to do this. So what I do right away is I'm just going to do that. Okay? I know it's going to move to the left. So it's going to follow the format of y squared equals 4x. Which means, what do I set equal to 4p? Negative 16. So 4p equals negative 16, which means my value of p is what? Negative 4. So I know that my center, my vertex of this parabola is going to be at the origin because there's no shift today. I know it's going to open to the left, so I just make a little sketch of this. Doesn't have to be perfect. And I know that my, yes ma'am. No, not right now. Yes ma'am. I know that my focus is going to be 4 spots to the left of my vertex. Well, what's that ordered pair? So my focus is at -4, 0. Directrix is where? At x. That's how you do it. You have your other calculation? Ask somebody to borrow one. Somebody lend her one, quick, quick! Remember, the distance for, yep, this value is, you went left for, which means this has to go right for. The center of these things are always going to be equidistant to both parts. I used, okay, this, great question. What happened to the x? Well, this equation is mirroring this. In order for me to worry about anything, since I know my center is at 0, 0, I know that this 4p value has to equal -16. So I don't have to worry about any other x part yet. Eventually, we will get to the point where it's going to be y minus 2 quantity squared equals 4 times x minus 7. And I'll have to figure that out. But what's your value of p in this case? It's 1. It's 1. Because what's the value? It's 4p, right? What's 4 times what's 4? 1. Where's your center? Where's your h and k on this? 7 and 2. I just made it up. So the idea, got it. The idea of where this stuff comes from, to be able to solve out of this, will allow us to do this stuff in about a week. All right? Believe me, it seems like, what the hell is going on? It's not that crazy. Seriously. Seriously, it's not that bad. Okay? Okay? So 7 equal. Excuse me. Oh. All right. All right, right off the bat. Is this an x squared or a y squared problem? X squared. What direction is this going to have to open? Going to open up like a cup. Why is it going to be open up like a cup? It's positive. Okay. I know that's going to happen. So what I do then is write out. Well, it's going to be an x squared equals a 4p y. Well, what do I set 4p equal to? 1/32. So 4p. So what I do now, well, it's not, no, you're off, 128. So you multiply both sides by a 4, basically the same thing here. So your p value is 1 over 128. Okay. So how far is the focus from the center? Not far at all, is it? Okay. We know it's opening upward. There's my center. Opening up. There's my focus. The focus is at the ordered pair of 0, 128. Do I have to try and count it out correctly? No! Because what we're doing here is we're giving a rough sketch idea of what it looks like. I know that my focus is at the ordered pair of 0 and 128, which means my directrix has to be at the equation. The horizontal line now Very good. Y equals negative 128. Because the idea here is, remember, this distance and that distance is the same. I don't care if it's a fraction. And that's why I was saying, don't freak out. Who cares? You're just rough sketching it. It doesn't matter your scale, guys. What we're looking at doing here is, can we identify the parts and label it? And that's the point. Literally. Yes, ma'am. Correct. The directrix is a line. The directrix is always going to be a line. It's either going to be a y equals or it's going to be an x equals. Yeah. No, it equals y if it's up like a cup or down like a frown. It's x if it goes left and right. Because remember, the idea here is that your directrix, you want to cut through both of them. Or remember the short little trick that I said a second ago. X squared equals 4py. Y squared equals 4px. Y squared parabola has a y directrix. I'm sorry. X squared parabola, the x squared parabola has a y for a directrix. The y squared parabola has an x for a directrix. See how it kind of bounces off like that? Nice little trick. All right, it's a nice little trick to know. All right. Man, it's weird, but trust me, it's not that tough, is it? Shouldn't be. All right. I gotta fill time on it. All right, we'll finish up on that one. We're gonna fill time. Yeah, you don't want to solve it like that, do you? What do you gotta do? Nope. Think about what the generic forms look like. Y squared equals x something, or y squared equals 4px. So right away, I'm just going to write it as 3/4 y squared is x. So 4 multiplied by 4/3. What's that? Because all of our generic formulas have it as y squared equals 4px. So now, what do I set equal to 4p? 4/3. I have to set 4/3 equal to it. The x is remember, there is a generic multiplier here. I am solving for p. I am solving for p here. No, we're solving for p. The x value is always there. The x value is just telling me that since it's a singular x, it means it's going to be a y squared press going to move left or right. Okay. What we're doing here is we're figuring out what times 4 equal 4/3. I'm sorry, what? We're going to add in the shift next week. There's like instead of being at the origin. Right. But remember, that just means, shh, guys, that just means you have this right now. That just means right now you have this. Because then we'll put in the H in there. But the prep work for the problems don't change. Prep work doesn't change here, okay? So what's my value of P? 1/3, good. So my value of P is 1/3. The y squared parabola, positive value of 1/3, what direction does this open? To the right. It's going to go to the right. Y squared to the right. P-value of 1/3, which means my focus is at the ordered pair of, how about 1/3 0? All right. And my directrix will be located at x equals, very good. Yes, sir. What's that? Yes. Okay. What his question was, guys, I don't know if you heard him. What are we solving for? Well, remember, right now, everything is centered at the origin. And what we're going to do is we're going to rough sketch these by figuring out what the value of P is. What happens here basically is the value of P kind of tells you how fat or how skinny the parabolas open up. If you think about it, y equals x squared, it's just standardized. If it's 2x squared, it's tighter. So it makes it a closer parabola. If it's a 1/3, 1/2, things like that, it opens up further. That's what allows you to figure out this scale, if you will, of how far or wide something's opening up. That's what that does. That's what the p-value does for these things. For us, that's not that big of a deal. What's going to happen here in a little bit, and I have an example of it here, is that I'm going to give you a directrix. What's the equation? That's what we're going to be able to do. By understanding what the parts themselves mean and how they are located within the diagrams, it's super easy to figure out. For example, if I have, where is it? Write the equation in standard form with the vertex at 0, 0, and the given directrix. Y equals 2. Well, first of all, they're giving you the ordered pair for the vertex. Y equals 2. Where does that go? It's a horizontal line at. So if my directrix is there, what direction does the parabola have to open? Downward. What equation are downward parabolas? That's going to be an x squared parabola, isn't it? It's an x squared parabola, which means how far away is the directrix to the center? 2, which means how far away is the center to the focus? 2, which means my p-value is, but I move downward, -2. That means my p-value is -2, so my equation is going to be x squared equals 4p5. Well, p is -2, so x squared equals -p5. By knowing where things are located and the relation to the center, or the if I know that I have a directrix and a focus, the midpoint's the center, isn't it? Because they're equidistant from each other. It's the idea of being able to take that small bit of info and move it into it. Okay? And it works with whatever you've got. Knowing what the p-value gets you. Okay? Try another one. I know you guys are still writing that out. And again, this is a super visual section. Like this whole conic stuff. It is one of the most visual things that we do, aside from trig later on. But for right now, draw pictures. Get a good picture of these diagrams, because everything has a picture. And if you're able to draw a little bit larger of a diagram, and I was showing Sarah this about first hour, but she was in flex, then a lot of times as we get into these things, we're going to have A values, B values, C values. Parabolas have P values for focus. If you understand where everything gets located within a diagram, solving these things out and writing these equations become extremely simple. It's just knowing how to picture it. And that's what we're trying to start with today. Okay? So again, we have the center is at the origin. Everything's at the origin today for the next few days. And let's say we have a focus at -4 and 0. All right, say we start with that. What's the first thing you're going to do? Draw it. Yeah, draw it. Remember, bye, Devin, I'll have it posted. Here's your vertex. Where's your focus? Left, right, up, down. Left. How many? What way do these open? It always opens towards the focus, doesn't it? This opens to the focus. What kind of parabolas open to the left? X squared or y squared? Y squared. If the p-value, if it's opening to the left, is my p-value positive or negative? What's my p-value? -4. So I have a y squared parabola with a p-value equal to -4, which gives me an equation of perfect. That's what you're able to do with these things. That's exactly what you do with these things. Because you understand which direction things open. Everything's centered at the origin. If it's centered at the origin, what's up? Why is it negative? When you're thinking about why is it negative, if I'm moving to the left, is that a positive or negative way? Because the p-value is always the distance. All right. I know that I always say distance is positive. Think of the direction in this case. The p-value moved to the left. So gotcha. So the directrix that would be at 4 would be x equals 4. Okay. So remember, I know that we always say distance is positive, but this is just telling you the direction that you're moving. This is one of those things that you're moving to the left, so you're moving negative. You're moving down, you're moving negative. Moving up, you're moving positive. That's what you just have to take into consideration with some of these things. Okay. One more? They're all at the origin, man. There's nothing complicated to start with this. What we've got going here with these things is that it's going to be every other odd. I've got the ones that ask you about graphing. The ones that ask you about graphing, when you graph them, it's just a rough sketch, guys. And just label like I did. Where's your focus? Where's your directrix? And then the other ones are going to be write the equation, given a directrix. Write the equation, given a focus. Again, it is super easy to just rough sketch it. That way you know what direction things are opening. All right? Now, one of the things I will show you real quick that the calculators do, you guys have that button that says apps? If you don't have if this doesn't show up, I think all these are all the newer ones that should show up. Option 4 is conics. Option number 4 is conics, and it shows you all the generic forms of all the equations. So right now we're talking about hyperbolas. Now, this is what the form is going to look like when we shift them. But for right now, if you think about it, our H and K's are all located at 0, 0. So this is non-shifted form. So what's nice is that and it also tells you what direction things move. If it's a y squared parabola, see how it's moving, it has a picture here in blue that's moving right? It's going to go right or left. The x squared parabola is showing that it goes up, it means it can go up or down. You'll never have to memorize these formulas, but what you will have to do is you'll have to know how to use them. Now, it doesn't mean that I'm going to let you use this calculator per se on this. It means I might just give you the formula. It's one of those things, okay? So you guys know where things are at. Questions? What's that? You don't have that app? It's no big deal. I can always download it to you. It's I just need a power card. We don't need them yet. I'm not worried about it. I'm not going to worry about all these different formulas and stuff like that, so we put everything together. Because each day you're just going to be looking at one formula for right now. Tomorrow, what you guys are doing, which again, I know you guys have all done. Circle, right? Do you guys remember the equation of a circle from last year in 10.7? You have your circle packet still? All right. You guys did x minus Oh, how do you write it? They might write it as x minus h. They do that? You did, but I think they may have done it. No! What's up? You can do so, but yeah, we'll do this, but again, our centers are just going to be at the origin. One thing I will talk about, do you guys remember this? Tangent. Mainly tangent stuff. When two things are tangent, when they're tangent to a circle, what are you to the radius? Perpendicular. What do you know about perpendicular slopes? Very good. How do you solve? If I have a slope of 3, what's its perpendicular? No! -1/3. Very good.